Do you want to know how to secure the ERC-20 implementation? Stay solid, because today we'll safeguard our token and make sure all the transactions go as expected. Hello and welcome to the Decentralized channel. I'm Miguel, and here we share content about Web3 and blockchain development. So first thing that we'll do is to finish our contract. What we're missing here is the events. We can copy it from ethereum.org and drop them here. So we have our events declared, and now we are going to secure our functions. We will start with the transfer. Oh, there's another thing here. We need to set the balance of the message sender here in the constructor equals to total supply. This will give the full supply of tokens to the wallet that deploys this contract. For now, it will be just as good. This is not the safest way to do it, but we will take care of this in another episode. So in our transfer, we will need to make sure that the to address is not the zero address. So require to not equal to address of 0. This will raise an error using 0 address. So we cannot use this. If we did allow to use this, this would do the same thing as burning the tokens, because we cannot do anything as soon as we transfer some tokens to the 0 address. We cannot withdraw them, we cannot move them. So it will be the same as burning the tokens. The second thing that we are going to do, so we don't need to make sure that this owner is not the 0 address, because the transaction will have to be signed, and since it will have to be signed, it cannot be the 0 address. You cannot sign with the 0 address. So the second thing that we need to do is to guarantee that the balance of the owner is enough. So it will be less than or equal to this value. So we have to require that balances of the owner is lower or equal to the value, else insufficient balance. Nice. Okay, and I think this is it for this function. Now what we are missing here is to emit the transfer event. The transfer event takes the from and the to addresses and the value, and this is it, just as easy. And now we will take care of this transfer from. Now here we are going to do the same, to require that the from is not the 0 address, using 0 address. We don't want to use the 0 address, it's a bad thing. The same for the to address of 0. Let's copy this because I'm lazy. Okay, so now we will also guarantee that the balance is enough, is greater or equal to value. I think I made a mistake there. This is also greater or equal to value. If it's not, we will raise an error saying insufficient balance. Looking good. Another thing that we'll need to do is to require that the allowance is enough. So we will do the same thing for the allowance. It's greater or equal to value. So I think we have all the requirements here, and now we will emit the transfer event again. So we did a transfer from, to, and with the value. Oops. Here. Okay, now something is wrong here. Yeah, so we need the owner address, owner equals to message, not the owner, sorry, we need the spender, equals to message sender. Now this is why, because the allowances are not to but addressed to the spender. So when we request an allowance, it will create an entry with the from, so where we want to withdraw funds from, but the spender will do the operation. So this will have to be like this, spender here also, and from to value, this is okay. And now this is the last one that we need to take care of. We don't need to care about the owner, because if the owner is the message sender, it will have to be signed and it cannot be the zero address, but the spender can. So we need to require that the spender is not address of 0 using 0 address. Nice. Okay, we don't need any safeguards here. We can approve an allowance even though that we don't have any balance, because we can put balance afterwards, and the allowance is just fine. Okay, I think this is it. Now let's go for the tests. We need to also refactor a little bit of the tests. Let's create a fixture that will just construct our contract and deploy it. I will use something that I have here already. Okay, so what we're doing here is to create a dictionary with the wallets. So we have the deployer we are getting the signers from ethers. So we have 4 users, 1 deployer which will deploy the contract, and 3 users that we can use at will during our tests. So right here we are constructing a factory, then we are deploying the contract, and we are checking all the stuff, the basic stuff from the contract. We are checking the total supply, and we are going to check if the balance of the deployer is the same as the total supply, which should be. And then we are giving some tokens to the users, checking if the tokens were given, and returning the token and the wallets. So I'm just going to copy and paste the tests that I did offline. There is something missing here, which is the import. Okay, so I think we're up to. Let's try to run the tests. And it's npx hard hat test. Let's see if it runs properly. Oh, it didn't. Expected event approval to be emitted, but it wasn't because we didn't emit the event. So here in the approve, we will need to emit approval, and the approval takes the owner, the spender, and the value. Let's try again. Haha, it ran. Nice. Okay, so since we got a very nice test here, please smash that like button. Don't make me go there and smash it for you. Do it and follow us for to be notified about new videos. So now that we have the tests, I think we're done. We just finished the security part of the contract. Now there's another thing that I would like to do, which is to set up the gas counter. So there is something that it's called in hard hat, which is the gas reporter. And what we need here is now gas reporter, and we need to enable this. True, and another thing, show time spent, also true. Now let's see the difference here. Running the tests. Okay, so as you can see here, you have a very nice table with the amount of gas spent on each operation. So we have the transfer and the transfer from and all the gas spent if it was running 200 times. And this is the gas spent on the deployment of the contract. So this is it for this episode. On the next one, we will optimize the contract and use this table to see the optimizations that we are going to be doing on each iteration. And that's it, guys. I had a lot of fun on this one. I will have a lot of fun on the next one also. See you on the next episode.